Okay, a series. Mathematically, a series is different to a sequence, but they often get joined together in the same topic, sequences and series. Now, a series is actually a sum of a sequence. So they are related because a series is a sum of a sequence. So if I have a sequence here, it's an arithmetic sequence, so it's got a common difference. In this case, you add 1 from each term to get to the next term. And we start at 3. Okay, so we can denote this sequence by a recurrence relation. So this definition here on this line is referred to as a recurrence relation, which I will elaborate a little bit more on in a future video. Recurrence relation. The first term is 3. We can see the first term is 3. And the next term in the sequence, which is denoted as ak plus 1, is equal to the previous term plus 1. So if we wanted to plug in k is 1, then we would get a2 is equal to a1 plus 1. So a2 is a1, which is 3, plus 1. a2 is 4, which we can see is true. And this recurrence relation defines the sequence. But of course, you could actually define the sequence in terms of the kth term directly. It's a very simple sequence, it's a linear sequence, and ak is just going to be k plus 2. So the fifth term of the sequence is going to be 7. Okay, 5 plus 2. The 100th term of the sequence will be 102, because it's 100 plus 2. Okay. The recurrence relation is limited because to find the 100th term, you would need to find the preceding 99 terms. But this is a much better definition. This is the direct definition of the sequence. Same sequence, same definition. This one is a bit easier to work with. So the sum of a sequence, well, it's obviously an infinite sequence, so we're only going to take a part of it. Because otherwise the sum would be infinite as well, in this case. So let's do 3 plus 4 plus 5 plus 6. So that is the sum of the first 4 terms of this sequence. So 3 plus 4 is 7, plus 5 is 12, plus 6 is 18. So that is the solution. Or we could sum the first 5 terms. And that would come to 25. And we can notate all this with sigma notation. And sigma notation allows us to express a sum such as these two in a more compact way so that we don't have to write them all out individually. It's called sigma notation because it uses this big letter here. This is a capital sigma from the Greek alphabet. And it means the sum of. So this is the Greek letter sigma. That's capital sigma. There's a small sigma as well. And it means the sum of. It's literal translation, if you like, mathematically. So we're going to sum some terms of the sequence AK, which is defined up here. Okay, AK is k plus 2. And this sequence here, this series was 3 plus 4 plus 5 plus 6. That was the sum of the first 4 terms of the sequence. So that means we're going to go from k is 1 up until 4. And that is notated on the sigma. K is 1 up until k is 4, and what this represents is A1 plus A2 plus A3 plus A4. Okay, that is what it translates as mathematically. Okay, that's what it means. So this more compact form allows us to express this sum here in a more compact way. So we will be able to say that the sum from k equals 1 to 4 of AK is equal to 18. And you need to be familiar with this notation because it can come up in examinations. The next one was the sum from k equals 1 to 5 of AK, and that came out to be 25. And that is the definition of a series and sigma notation. Thank you for watching.